All right, the audience. There we go. There we go. All right. Several years ago, I came into the hospital, while I was on call, and it was unbelievable. I came into a critical care room, and it was like Medlin. There was chaos, and there was a family in one corner, the doctors and nursing staff on the patient, because the patient was coding, and they're like performing CPR. And they all looked at me and said, "Get this monitor up and running because we needed to save the patient." Here I am, never done anything like this before, going, "Oh, what do I do?" But I went in there and I looked, and I actually got the monitor working. And lo and behold, the patient did get saved. Nothing by what I did, but I had that small part to play. That small part in helping the patient. And that's what biomedical engineers do. We have that small part to play to help the patient get better. I've been in this field about 20 years. I've got a degree in electrical engineering. I've been certified through AMI, the Association for Advancement for Medical Instrumentation, the leading organization for our field. I've been doing this for years, but it never dawned on me till that moment that life was precious, that here we are, we come in every day, we do our deeds, but life is precious. As I became a believer, as I became a Christian, I noticed that through my learnings that, God values life, and here we are helping in our small part to value human life. No matter what we do, that's kind of what biomedical engineers do. So, the question that comes into play is, what is biomedical engineering? Based on the United States Department of Labor, there are two facets for biomedical engineers. The biomedical engineer, which applies engineering and materials technology, to healthcare. In other words, they theoretically go onto the table and build a piece of equipment. They build the medical equipment. Biomedical equipment technician, we take that theory of operation, we take the underlying physiological principles and the safe clinical application of that equipment, and we take that and we do a hands-on. In other words, we take care of the equipment. We fix what they make. Biomedical engineers, they build it, we make it. So therefore, we have to have a lot more knowledge than biomedical engineers. Doctors and nurses, they have their specialty, labor and delivery, cardiology, neurology. Biomedical engineers, they have to have knowledge across the spectrum. We have to understand everything from this little suction regulator to, the Da Vinci surgical robot. We have to have the education and the know-how to make healthcare safe for the patient by looking at everything that's medical equipment. A friend of mine, Bob Stiefel, who was the director of University of Maryland and now is a specialist who goes around the United States to other hospitals for their biomedical departments. He once said these technologies support medical and surgical procedures and thus have a direct impact on patient outcomes, patient safety, and operations value. That's what we do. We are part of that. We are here to make the patient safe. That's what biomedical engineers do. Part of what we do, and it's a big part, but part of it is patient safety. What do? We fix equipment, yes, but what we also do is we look at the equipment to make it better. We work with the FDA by reporting certain things to make the equipment better. There are incidents that happen throughout the healthcare system, and medical errors throughout. And Dr. Lucien Leet once said, medical errors often result from a complex interplay of multiple factors. Only rarely are they due to the carelessness or misconduct of single individuals. In other words, most mistakes happen because of a piece of equipment, generally speaking. And as biomedical engineers, we have to be aware of that. We take that concern to the FDA by using the Medical Device Safety Act of 1990. We're able to report to the FDA human factors concerns. Human factors are, how does a piece of equipment work? What is it about? So as biomedical engineers, we take the human factors concerns, expectations about how a piece of equipment is supposed to work, device alarms, device labeling, is the screen clear, the keypads function properly, the physical size, shape of the equipment. We take all of that plus a lot more, and we report back to the FDA to give feedback to the biomedical engineers on how the equipment is supposed to work better. We report it. That's what biomedical engineers, that's part of our job function. Make it safer for the patient. So based on that, just to kind of give you guys an idea, that biomedical engineers as a field, throughout the United States, based on the statistics in 2008, here we are. There's only 16,000 of us in the United States. That's it. Not a lot compared to the 1.6 million. But yet, the growth potential is amazing. Based on this U.S. Department statistics, biomedical is supposed to grow 72% by 2018. The growth potential for biomedical engineers is outstanding. That is what we do. This is the growth potential. So as biomedical engineers, you can get into the field, be part of that health safety function of the United States healthcare system, and that's what we do. So just to kind of give a feedback, what it boils down to is biomedical engineers. We're here to help the patient. We're here to keep the patient safe. And by the way, we're here as well that the potential growth. We're going to be able to find jobs across the United States. That's what we're here for. We're here for safe, and the job potential growth is amazing. And if there are any questions after, please come and see me. Thank you.